Hello programmers, Spidy is back with another video. So in this video I am showing you how you can build a emotion recognition system using your facial expression with a Keras library. We are using a convolutional neural network technique with the Keras library implementation. So let's see how it works. So first of all let's see result. Actually guys, I have uploaded this video on yesterday evening. So this is the result. So actually, guys, I have implemented this thing 1 year ago, but this project is implemented with a mobile net model, which is the concept of the transfer learning. But this time I have implemented this thing with a Keras, not with the transfer learning concept. So guys, I will make another video of this system, emotion recognition system, but another video will be based on a transfer learning concept, which is more accurate than this result. But actually, on the transfer learning concept, on the transfer learning system, result is a very slower than this Keras result. So let's see how build this kind of system. So we are starting from the scratch. Okay. So first of all, see what you have to do. So just guys, you can do this procedure on your CPU and GPU also. So currently I'm doing on GPU. Even I have tested this thing on a CPU. You will get amazing result on CPU also. There are no lagging on the any type of the video. Video detection is also faster. So let's see how it works. So first of all, create the one folder on your working directory. So I have created one folder on a desktop. In desktop, you have to just create a two folder. I have created data folder and a training one folder. So sorry, training folder. So in training folder, it will store our models and hypotheses, and in data folder, we have to store our data. So first of all, let's see how we gather the data. So guys, you don't need to do anything. I will provide this Jupyter notebook link in description. In this notebook, there is the all code available. You don't need to run any code. All the code is available in this Jupyter notebook file. So just you have to do step by step. So what will be our first step? So we need to gather the data set first. So guys, there are lots of facial expression data set like Canada data set, and even there are more data sets available on the Kaggle. But guys, actually I have created my own data set. So if you don't know how to create data set, then a video link will be, click on info link, just it will show how you can create the data set. So this code will create your data set. So first of all, understand what this code is. This I imported CV2, then I start the video capturing. Then I just define video frame is equal to 0. It will count the frame. Then actually what we have to do, it will open the one camera frame. Now when your video will start, then you have to just give expression. So first of all, let's see if I am collecting expression images dataset for neutral. So when this video will launch, just you have to stay your face neutral. So it will convert all of the your video frames into images and store images like this. So you can see there are the neutral images of my face everywhere. So I collected 380 images for my data set. So just you have to change the name. You have to in directory you have to give the path data directory. In this data directory you have to create one folder for one emotion, for a neutral. Just then I have stored the image. Now you have to do once again this procedure for happy. Like if you want to store happy images, so just give the name of folder happy, or we can say smile. So give the path of smile, and once again launch this code. It will store all of the data like smile data set. So once again you have to do it same for another expression. Even you can add a more expression. I have just given 4 expression. I have given angry, neutral, sad, and smile. So that's how you can generate the data set. Just you have to run this code 4 times. But before this code running, you have to create a 4 subfolder in data folder. First create angry, or based on expression which you want. So first of all, let's create this kind of folders. After that, just you have to give path of the folder, just a name of the folder, and it will store all the images in that particular folder. So just I'm showing you my data set. So in shared folder there are 381 images. There are 381 images on smile folder. There are 381 images on neutral folder. So we can see our data set is collected very easily. It will take around 5 to 10 minutes to generate the data set. Not much time. So now our data set gather is incomplete. Now it's time to dataset pre-processing. So we need to pre-process our data. Okay. So let's understand the data. Now just I'm showing you one image. Now I am opening one image. Let's see. So guys, this is me. So just see. You can consider this whole image. Now in this image, just we have to focus on our faces. We have to focus on my face because my expression result will be on my expression. So most important part of the image is what? My face is the most important part of the image. We can say this all other thing like there are the tiles of background. You can see there are tube light on many other things which is available in the background image. So this is not important for us. So now we need to do image processing. So what we will do, we will detect the face using her cascade technique from the every and each images and store that images in one numpy array. So let's see how it will work. So just I will give an idea. So first of all, we need to access the folder. So here just I used the CV2 and OS library, CV2 for image processing, and OS library for just operating system related task. Then I just you can see. So let's once again I'm running this once again. So just see. So you can see our list is created. There are 4 types of folder. Now that's 1 minute ago I have told you we need to pre-process the image. So same thing which we are doing in this part. So first of all we are iterating one by one folder each or there are 4 types of folders. So first we will go in angry folder, then in angry folder we will look into all the images. So we can see now in all the images we have to find the faces in all the images. So that's why we are doing list comprehension here. So we are doing x, y, w, h, means this is the face coordinate, x, y coordinates and width height of the face. After that, in this line, we are cropping the faces because our expression which is available in our face. So we don't need extra another background for the our neural network. Just we need to feed our main features. Our main feature is our face and expression. So we are cropping our face. Okay, after that we are converting into black and white, means gray filter, because if you are doing something related to neural network prediction, then gray image is a much more better than color image. After that we are resizing our image because we need to resize our size. So our by default height and width is 100. After that we are not generating a new images. Instead of doing this, it will take a too much memory. Instead of this we have created two kinds of empty list, data and target. So in data we will store our array values of the images which is cropped, which is available here. So we what we did, data dot append and resize. After that we need to also find give the label of the images, like which kind of the image is this, like this image is for angry, this image is label is happy or sad or neutral. So in another list what we are doing, we given label directory and category. So it will store the label of the images in target file. Okay, after this we need to reshape our data. So we are doing normalization process here. Just we are reshaping our array, and after reshaping array we are converting our labels into categorical values, and finally we are saving our data and target into npy file. Because if you don't know what is the npy file, so it is a one kind of numpy format which will store one kind of npy file. So let's see how it looks. So first of all, let's see give into demo. So it will store our all the things into training folder. So let's go to training folder. You can see there are file of data.npy and target.npy. So in data.npy there will be our images data. In target.npy we have the labels. So with this code it will show our images. Now it's time for the training. So before training we need to load our labels and data in our main memory. So what we are doing, actually we can do this task is directly, but just for a reference I store this data, but we can do this thing directly also. So just I will use np.load method which will load our data and target. Now it's time to the most interesting part. We are defining our Keras model. So we are using sequential neural network. So guys, if you don't know what is neural network, then you can search literally on internet. There are number of research paper available. You can learn a neural network. Neural network is a very easy concept. Just if you need to understand this concept. So first of all, we are importing a sequential model, then dense, activation, flatten. These are all the important things of the neural network. So we need to import that. After that, we are giving a layer. So here we making one layer. After that we need to feed our data into layer. Once again here we are making another layer. So guys, if you know what is neural network, guys, I am not giving all the neural network info in this video, but otherwise this video will be longer, very longer, and I know the people mentality, just people focus on the code instead of the logic. So just I am giving a basic explanation. So here our first layer, after that we add the second layer. After that there is a flatten layer which is most important, and end of the neural network we are giving our output layer. So there is a one strategy here. This is our final end output layer. So we call it dense. So we need to set the dense layer at the end. Now I have defined 4 here. So this is what 4. So 4 means we have output which is available in 4 category, because our emotion is what? Our emotion is the 4. We can see our emotion folder, we can see angry, neural, sad, smile. So that's why I defined 4, because we have the 4 classes. If we have 5 classes, then we have to define 5 here. Then we are just giving model compilation. After that here we splitted our data into training and testing. Guys, if you don't know what is a training and testing, so just one kind of validation technique. With this technique we know how our model is perfect. Now it's time to the training. Here I have did the training. Now I'm storing my epochs and my file as a model file, because I need to access once again that file. So here I will choose the 12 epoch. If you want to more accuracy, so you can change this layers also, and activation technique also. Here I define ReLU and softmax function. Here I just choose a categorical close entropy loss. Here I use the optimizer as a atom, and matrix as accuracy. So guys, you can change many things here. You can achieve a more better accuracy. So it depends on you. After that here I have started training. So first of all let's focus on the epoch. So guys, you can see my on the first epoch my loss is very high and my accuracy is lower, but epoch by epoch my accuracy is going better. You can see now my loss is on the 4 epoch my loss is 0.06 and accuracy is 0.98. So you can see my accuracy is increasing. So guys, you need to just remember one thing: your model should not be overfit. Overfit means it's a 100% accuracy, and your loss will be like 5 point or 6 point or 6 point something. Then we can say this is the overfitting. So after that we have plot the graph. So with this graph we can see our how is our model is accurate during validation and training. So guys, you can see, observe this graph. Just we have to run this thing. So we have plot our graph here. and this is our training graph, accuracy graph, you can see. So with this graph you can assume that how your model is accurate. After that we need to evaluate the model. So during model evaluation, even I got the 100% accuracy. Actually, I know my model is a little bit overfitted. So just guys, this model is overfitted, but you can changes. You can do changes in your strategy. Also, you can add more layers. You can extend the more epochs, and you can change the activation function and strategy also. So guys, I am also doing the same thing. I am changing my model parameters. Like it's like a try and error. It's not like every model should not be perfect. You need to try and error and check your model. It will give a one day very good accuracy. So that's the life of the machine learning engineer and data scientist. Now our model is saved. So in training folder, we can see our model epochs is saved. So we have to consider our last epoch. So my last epoch is a 009. So once again, now I have to define model. So from keras.model, there is a method load model, then import cv2 and numpy. Now it's time for to do the prediction on the live video feed. So in load model, I have to define my last model path. Then I will define the hard cascade file. After that, we have downloaded one video from internet, which is welcome video, which I uploaded yesterday. After that, I have created one dictionary. So your dictionary label should be according to your folder wise. You can see my angry, after that neutral, after that sad and smile. So this folder indexing should be same as your directory. Actually, I speak it wrong. My dictionary should be based on this folder indexing. After that, I have given different value, guys. I got the some of the comments. I need to change the color because in neutral it's showing a red and on angry it's showing green. So because I don't change the color, just I got the I enter the random values in the color like 00 to 55. Just I put some random RGB value and I don't know what will be color. So guys, you can change the color here. So this is our color dictionary and this is our label dictionary. Now it's time for the main part actually. So now we need to read our frames one by one. So we need to obviously go into infinite loop. So here what I did, cap.read read by our frames one by one. After that we are converting our frames into gray. After that, from that gray images, we are finding faces. After finding that faces, we are cropping that faces also. After cropping that faces, we are resizing our face into 100 into 100 because at the training time we given 100 into 100 image in our training. So that's why we need to give 100 into 100 resized image during prediction. After that we are doing normalization here. After normalization we are reshaping our array, and finally now our it's time to give our reshape array to our model. So model dot predict the result. So actually model will give us a 0 1 2 3 output. So we can see here 0 for angry, which is actually I have defined in dictionary, 1 for neutral, 2 for sad. Because we can't understand, it will give output as a 0 1 2 3. So we need to initialize our label with that prediction. So we need to get the label from this result. So that's why I used a np.argmax, which will give us the proper result. After that we need to define rectangle. Rectangle, you can see guys, there will be rectangle on the face. So we are defining rectangle where face is detected. Now you can see main part is here. Now we will got a label. So which label we will got? We will get label in the 0 1 2 3 form. So what will be label? Label will be our prediction. So we will get 0. So 0 means our prediction is angry. If we got the label, then it's neutral. If we got the label as 2, so then it will be sad. So we are doing what? We are doing color changes here. So in color dictionary, If we got a one label, okay, so one label color is neutral, one label is a neutral, and one label dictionary color is I think it's a red color. Oh, sorry, it's a green color. So if label is neutral, then it will make the green rectangle and green label. If a label is zero, then it will print a label angry and red rectangle and red font means red label. So that's why we are putting text here. So guys, this concept is like silly, some tricky, but it is very easy to understand. Just we have initialized. That's why we have initialized dictionary here. So it will get the automatically value from the prediction, and it will change the color automatically. We don't need to put the if and else condition, like if uh, prediction is zero, then we have to put this text and this kind of color. It will do just automatically. So after that, we need to just im show means cv2.im show open the our frame, and it will show our result to us. Actually, let's I comment this part because I don't want to write my video. If key is equal to 27, if I press the escape key, then it will exit. If rate is equal to false means if I don't get the frame, then it will break. So I'm not starting the training, but I need to run this part to show you the result. So let's see which videos I define. I have defined vb1.mp4. So waiting for the result. Let's see first of all vb.1 is available or not. So guys, you can see the result is here. On the angry faces it makes red, and neutral face it making green. So guys, we can see our label is continuously changing because of our accuracies. We can see our model. Actually, I see my model is overfitted, so we need to actually lots of the changing. But guys, you can make the changes. So I just given way to you. This is not the perfect result. Actually, I know the truth, but with the deep learning and transfer learning approach, I have implemented a emotion recognition system which is very perfect. After that completion, I will show you the demo. But it is this system is a very laggy. It is a very faster than that system. But I can say this result is much better, not a perfect, but we need to improve this result also. So I am doing just lots of customization, but you can see this result is very good. So let's break it. So if you want to know transfer learning emotion recognition system, so just search Spidy 20 on Google. You will find my GitHub link there, and you can see first repository. Actually, I uploaded this repository around 1 year ago. So see the result here. I have created a Python application which can do analysis of your emotion, and it will launch the music player also. So guys, you can see this thing is implemented with the transfer learning, and it is much accurate, but actually it is slower. So guys, this thing actually I sold in China. This is my freelancing project. You can see this guy also won the award because of my work. So guys, you can also use this code. I will give all the description here. But in this video, I have did this with Keras, and this is the older version which I did using TensorFlow mobile net transfer learning concept. So you can refer this repository also. So that's for the today. Just now, guys, I am working on a darknet object detection on YOLO weights and YOLO technique. So I will be back with that, and until that I will upload more the videos. So just I want that you just subscribe the channel, so it will motivate me to do upload more videos like this. So like this video, share with your friends, machine learning enthusiastic friends. And if you did not get anything, just comment down. I will upload this repository on my GitHub. Just link is description. So guys, like and share this video, subscribe the channel, and don't forget to share this video with your friends. Until that, stay safe, keep coding. So thanks for the listening, man.